Hi everyone, I'm Cheryl. In this problem, we're asked to create a quadratic function that has solution points -3, 0 and 3, 0. Now, a quadratic function is going to be a parabola when you graph it. We're asked to find one quadratic where the parabola opens up and a second where the parabola opens down. Okay, so let's begin by taking a look at the factors that are required. I know that there's a relationship between the factors and the x-intercepts. And notice that the 2 points I was given are both x-intercepts. So let's take a look at the factors. If -3 is an x-intercept, then I know that x minus a -3 will be a factor for my function. And if 3, 0 is an x-intercept, I know that x minus 3 will be a factor. So I can create a quadratic function by taking f of x and setting it equal to x minus a -3 times the quantity x minus 3. Or in other words, the quantity x plus 3 times the quantity x minus 3. And using FOIL, I can write that as x squared minus 9. And this is one quadratic. Now notice that the leading coefficient is a +1, which means this one is going to be opening up. Now, I need to find some other quadratics that also have those two solution points. Now, how could I do that without changing the x-intercepts? Well, all you need to do is take your original function and multiply in front by a constant, any constant. So I can create a function h of x with the same x-intercepts by putting, let's say, a 2 in front of the quantity x squared minus 9. So that's going to give me 2x squared minus 18. Well, that's another quadratic that passes through the points -3, 0 and 3, 0. However, notice that 2, it's still positive, which means this parabola also opens up. I'm really looking for one that opens down. To accomplish this, the constant that I multiply in front needs to be negative. So let's call this function j of x. And I'm just going to pick a negative number. So let's choose -3. And again, remember, any negative number would work. So -3 times the quantity x squared minus 9. This is going to be minus 3x squared plus 27. And that's a parabola that opens down and passes through my two given points. I hope that was helpful. Thanks.